Hello, good morning, and welcome, everyone. I see we still have a few folks coming in, but maybe we'll get us started. Good to see everyone. Good to see a full room. Great to have be here right after the keynote with all of the energy that we saw from stage. Today we'll talk about how GenAI can help us with the challenge, the age-old challenge of application modernization. This is one of the themes that we see as this interplay between GenAI for cloud and cloud for GenAI, right? We really believe that GenAI, that there is a lot of synergy there, that there is a symbiotic relationship, that GenAI can accelerate the migration and modernization to cloud, and that no enterprise-grade use case of GenAI can really exist without being on public cloud. So that relationship is very strong. Today we'll talk about how GenAI can help on that migration and modernization to cloud. As a way of a quick introduction, I'm Leandro Santos. I'm a senior partner with McKinsey & Company. I'm part of our digital practice, and I lead our Cloud by McKinsey capability globally. And here with me, we have Aaron.
Hi, Aaron Bawcom, McKinsey partner. I focus a lot of my time on cloud, and I sponsor our global practice for the use of GenAI to be able to power technology modernization. I'm a technologist by trade. And Leandro and I are part of what we call the new McKinsey, where we focus on technical implementation and delivery at a keyboard level with our clients, which is probably different than you're used to from hearing from McKinsey in the past. And we're here because we're really excited to show some of the work we've been doing of how we can use generative AI to significantly accelerate and reduce the developer burden for modernizing technology systems.
So with that, the language of legacy systems and technology that is very well known, for age. The moment you write a piece of code, it starts to age, right? It may not show rusting like physical infrastructure does, but we all know that it does rust and age. And it's a problem that is very visible on the business side and the technology side. So on the business side, it slows down and limits the ability to change and innovate, for the business to respond to market pressures, right? For you to be able to offer new products quickly and all that. On the technology side, it just brings a ton of risks with it, right? Risks of resiliency, risks of continuity, risks on the cyberspace, and in several cases also it comes with a larger operating cost, a higher operating cost than what you'd be able to do more modernly, right? Now, if the problem is not new, why is it still there? And I think the reason why it's there is because all of the approach, all of the ways of modernizing that have existed so far come with a lot of challenge. So on the business side, the business cases are quite tricky, right? Because there has been hundreds of thousands or millions of development hours that have gone into the systems over the years, and they're kind of working. So justifying that business case is very, very tricky, right? Really quantifying what are the benefits, what are the costs to do it is not simple, and the costs tend to be fairly high, right? So that's one challenge on the business side. And then on the technology side, some of the systems don't have documentation. They sometimes don't even have the source code available anymore. Certainly, they don't have enough resource to go through the modernization. The business logic is not clear, right? And also this challenge on how much do I just modernize without changing, or do I want to change the business I modernize, and how do I do that? At the end of the day, the opportunity cost of tackling those projects tend to be too great, and other things get prioritized, and thus we keep creating technical data and accumulating technical data as it goes. Now, GenAI is a game changer on that equation. Right? It's a game changer because it allows us to automate a lot of the more labor-intensive and honestly tedious tasks that developers had to do to modernize an application. I'll walk through the application modernization lifecycle and how it helps along the way. But it does that. The other thing it does is it allows you to reverse engineer the business logic that's there, which then allows you to understand what the system is doing and test it more effectively afterwards, right? Those are some of the unlocks that we're seeing with GenAI as it applies to this particular use case. Aaron, do you want to maybe talk through how we have been using this?
Yeah, so the big unlock is being able to take a lot of that manual labor for subject matter experts within different areas of application modernization process and be able to codify what they do within workflows in a multi-agent orchestrated approach. So if you think about that labor that was having to read code and be able to understand it and document it, and a separate set of labor to take that documentation to be able to code it, another set of labor to be able to understand the data aspects, it's being able to orchestrate that through cognitive agents, operational agents, decision-based agents, and critical thinking type reasoning agents as well. And that orchestrated approach is where the most significant gains for the modernization process can actually come. And some of the kind of the so what of using this type of approach is on the right-hand side here, which is at minimal increasing the modernization process by 40 to 50% and reducing the cost by at least 30 to 40%. So if you think about, okay, now how does that break down even further? What are those agents actually doing? So if you think about a lot of the use of genAI today, you may take a piece of code and copy it into a prompt for an LLM to actually perform a transformation. And what you get may be fairly accurate, but how does that all tie together? What we have found is that there's not a magic button that you can press that just says, okay, convert this legacy system. Is that being able to tie in observability data and code and knowledge from subject matter experts and to be able to reverse engineer it into an intermediate state that describes the existing system from an abstract level, from a pseudo perspective that's not actual code implementation, allows for developers, product owners, product managers, and architects to look at the system at a higher level to decide, should we continue doing it that way? Should we modify? Should we add new features? Should we remove some capabilities? And then once that is shaped with a human that's actually performing that analysis, then use that to be able to generate the target state system where the last mile of human in the loop actually occurs. So breaking that down a bit more is that what type of data is used to be able to perform that analysis. So as Leandro said, it's not just code, observability data, any documentation that may or may not exist, business process and how the business process interacts with a particular legacy system, and then tying that together through AI synthesis with subject matter experts to complete the picture of, okay, this is really what the system actually does. And that's oftentimes a mystery. Some systems are 20 or 30 years old, people have moved on, and there's a lot of niche understanding that's just very difficult to be able to figure out. So just being able to document is incredibly critical. Once that documentation exists, that can then be used to be able to rationalize different systems. Many enterprises have duplicate systems. They may have this instance of this system and this instance of this system, but they're configured differently. They're for slightly different cases, but there's maybe an 80 to 90% overlap. And some systems, there may be even 9 or 10 different instances. So being able to rationalize what those systems are doing at a service level, taking that to generate the lowest level of technical specification, which includes how does this system fit into the overall business? What's the pseudocode? What are the logical flow? What's the data that's shaping it? And most importantly, the test cases. How do you know that a new modernized system is actually going to work? So you have to have those test cases as part of that specification. Once you have all that, that is then used to generate the target state system. So not translating line per line of code from whatever it was before to the new, but instead reverse engineering it to an intermediate form and then generating the new target state.
So maybe just one thing to add is, this is definitely more than a tool, and as much as we would have liked for a magic button to exist, that's not the case, right? And honestly, that's not what most enterprises need. So this is as much about the approach and the methodology that you do it, and creating that learning capability within the enterprise as it is about the several tools that are going to come in to support it. Now, it is anchored on real innovation and breakthroughs that are enabled through genAI. And those breakthroughs are around the application modernization lifecycle. So a lot up front in terms of reverse engineering those business domains, the business logic, the data structure, the data relationships, all of that, through then the point of reverse engineering and creating the documentation and the pseudocode and the technical design, which is where the human in the loop really comes in to be able to validate, change it, improve it, right, and act on it in a way that there is an abstraction layer where you can work through it. And then finally, on the last stage, to actually create the source code, not just the code itself in a modern language, but also the instantiation of that code in a way that can be managed in a DevSecOps type of way, in a way that you are deploying using infrastructure as code. Again, back to the point of this being a way of modernizing to the cloud or even modernizing to perhaps a software as a service type of solution, right? But really, not that line-by-line translation, but really thinking through how do I create a modern application out of it. And we talk about the 20 non-trivial engineering cases, right, or challenge that we feel like there have been breakthroughs in era. Maybe you can highlight a couple of them and bring this to life.
Yeah, some pretty exciting kind of breakthroughs here are, if you think about highly integrated monolithic systems where, let's say you have 10,000 functions across the system, and each function in turn calls 2,000 functions per. So it's this massive, tightly integrated mesh. So we've actually proven that it's possible using generative AI to be able to reverse engineer that system, to be able to first turn that into a hierarchy of a call tree, and then be able to use similarity scoring to be able to understand which parts of the call trees are actually similar to another, to be able to start abstracting those out into reusable components to start forming the basis of microservices out of that monolith. Now, we all know that that's possible to do manually, but having the benefit of large language models like Gemini and others to be able to do that analysis that is very rote and tedious to perform, being able to automate that at a very high speed actually allows for that mesh of code to start being pulled apart in that way. Another one is cross-interface bounded context synthesis. So what that means is, let's say that you have a call that comes in from HTTP that then goes to a message queue, and then it goes into a backend processing system for procedural logic, then it goes to a database, and then it goes to a database stored procedure. So all of that's a part of one bounded context. But how do you take each one of those code bases, each one of those separate portions of the overall value chain for that type of transaction, be able to understand it holistically, and then be able to document it, and then be able to generate that in a much more simplified form, potentially eliminating some of the stored procedures, understanding the data. So we've proven that that's possible. And the last is on the data side. We find that in a lot of large enterprises, that the data models that mature over 20 or 30 years can become incredibly challenging to understand. A lot of duplicative data, data that's misused or is not marked or tagged properly, categorized. So being able to take, let's say, thousands or tens of thousands of tables with hundreds of thousands of fields, being able to look at call patterns, being able to look at observability data to figure out, well, what really should the right enterprise data model exist for the business, be able to suggest that, and then being able to suggest that in an automated way, and to be able to automate the mapping of those fields, and then to automate the transformations that exist, the existing ETL that might exist within the enterprise into that model. Again, being able to use generative AI to significantly accelerate that process. So these are some of the individual breakthroughs that we've been really excited to experience. So we're going to bring this to life in a demonstration here. So if you think about some of the most challenging legacy systems, a lot of times they're mainframes. I think some of the market estimates is that 50 to 60% of the planet still operates off of mainframes. So they still are alive and well in a lot of large enterprises. And so that was one of the first use cases that we said, let's go take this approach and actually apply it for mainframe transformation. So in this demonstration, we've taken some open source COBOL code, and we'll go through and really provide an example of what this approach looks like. So in an integrated development environment, first we're going to see all the COBOL code and BMS maps and JCL. and we can actually start seeing a dashboard. Now we're going to start taking a look at, well, what does one particular code file look like? Well, this is kind of the COBOL code, and it's got a lot of the setup with copybooks, but we're going to get to some really meaty, nested if statements that may be difficult to be able to understand. And here, again, using the large language model to be able to synthesize that into documentation. Here's a high-level business overview. This is going to process credit transactions in a batch process on a daily basis. And here's the logical flow of what that does. Now, the product manager may look at this and say, well, we want to add some new error logging because we want to be able to get some more data back to be able to advise what we do. So we're going to actually modify the overview. We're going to modify the requirements for what this system should do. We're going to add that here. And then from there, start generating human-readable test cases, which are then turned to code. So these test cases actually prove that that system is going to work. And now you can actually see from the test cases, from the documentation, generating the target state code. So here you have the core application logic where we've converted from index flat VSAM files to SQL relational database data manipulation. You see the application code where it's actually API endpoints that are actually put in for the application code and the data models that are going to exist across all the programs that exist across the module. And then being able to see that manifest and be able to walk through it. Now, what you didn't see there was a developer typing code that then suggests something else to write. What you saw was a holistic view of the whole system where the developer was involved in every step of the way, but the work that the developer had to do was significantly reduced to be able to modernize it to a target state. In this example was Java, but being able to target other languages like Python or JavaScript was simply a matter of changing some of the prompts to be able to do so.
Right, so while this is still obviously in early stage, it's technology that's completely outside of the lab already. So we have been working with some of our clients on some of their trickiest legacy challenges and seeing real results in the order of the improvements that Aaron was talking about at the beginning. So Aaron will walk us through a case example with one of the preeminent US banks and how they're using this type of methodology to modernize one of their core systems and use that then as the MVP to scale that across other areas within the enterprise.
Yeah, so this case was super exciting because it was such a difficult system that the client had been attempting to modernize it several times over the course of several years and just wasn't able to. So when we started working with them, they thought this was a great use case to start with. So this included both online transaction processing through KICS, green screens, as well as batch processes for being able to compute a lot of data. There's a lot of real-time data that's also involved to be able to process. And here you can actually see the detailed architecture for the components as they are produced in a modern Java form of all the different components and how they're working together. You actually see an Angular user interface that was automatically created to be able to talk to API endpoints based off of the KICS transactions, being able to interact with the batch processes. So this is kind of bringing this to life of what it actually would look like for an actual mainframe application transformation to a more modern language like Java. Now, one of the big questions that we get is, okay, you know, this type of language translation has been around for a while. What does the code look like? You know, for some of those who may have gone through this, may have heard the term JOBOL, which is Java, but it just really feels and looks a lot like COBOL. So how do you really judge whether the code that's produced is really going to be good, maintainable code? So there's a Julia framework that's used to be able to measure and benchmark the code production from genAI. But what we find in addition to that is just plain old A/B testing with subject matter expert developers to actually look at, if I were going to do this myself versus what comes out of a large language model, how good is it? So here you can actually see scoring that came directly from the client. So this wasn't us, this was actually the client scoring on human readability, maintainability, correctness, accuracy across the code, being able to use some of the more modern coding standards that are actually used that one of their actual developers would. So it kind of brings it to life as far as what you're now going to actually maintain through this type of system. And last, this ties back up to really the beginning is what's the so what? What's the value in being able to do this? So being able to reduce the cost of technology modernization is really the ultimate goal. We all know that there's a lot of legacy technology or technical debt that may exist within our corporations and our enterprises, but we've never been able to make the business case to actually modernize it. When we look at what the cost associated with modernizing it, the costs are through the roof, and they're very expensive to be able to have a lot of that manual labor. So you can start to see here that this is some of the first early data around reducing the cost of modernizing these types of systems powered by genAI.
And in this case, this was sufficient to change that tricky business case that we talked up front and make it more clearly ROI positive, right? Especially as you take into account, back to my point on genAI for cloud and cloud for genAI, if you take into account that once you modernize this application, now you're also able to more easily build in new features that, for example, are using genAI for agents and whatnot, like we've seen on the keynote earlier today. So once you start accounting for additional upside, from getting into a modern system, as well as a much reduced cost to get there, all of a sudden, some of the modernization case that didn't make sense before, start making sense now, right? So that's one point. I think the other here is that we see the GenAI assisted engineering as a way, as the next wave of significant transformation in terms of software development, right? If we think about just some of the recent innovations from how we're using Agile to kind of break down development cycles from a waterfall to a more iterative and interactive way with the business, for example. How we've used public cloud to automate CI/CD pipelines and automate provisioning of applications, scaling up and down and whatnot. How we have, the combination of those two things have enabled us to institute DevSecOps methods within our development teams and make not just development, but the operations as well as the maintenance of these applications much simpler. We see GenAI now coming on top of all of those innovations. So if you look at it as a methodology, as an operating model transformation, more so than a tool that's going to assist an individual developer to write an individual file, this becomes truly transformative, right? And that's where that is what we're seeing. For example, on the case that Aaron just walked you through, is the power of doing all of that in a combined way. Right? So if we go to the next page, or do you want to add anything here?
Yeah, I think when I recall one of my favorite conversations with a CIO, to Leandro's point about this being really more than just tooling. That tooling is going to save the software development process. We used to develop software without Agile. We discovered Agile, and now we can't really envision developing without Agile. And then we used to develop without DevSecOps, and then we discovered DevSecOps. So I think that the use of GenAI as a part of the software development process is going to become quite prominent. And as one CIO said it, he said, I don't want one tool to be able to solve one problem. I have 100 problems. I need to be the ability to actually solve this across my entire software engineering process and all my software development capabilities and the developers that exist. So I think that's the trend of where we're going here.
Now, like I said, this is already outside of the lab, and the timing is now. So our recommendation is that, obviously, the use case, the problem, the specific challenge are going to be unique to each enterprise, right? So the first thing that we'd encourage you all to do, and we've been encouraging our clients to do, is to go back to those modernization use cases, those thorny issues that you have and you've had for a while, that just didn't quite make the cut in the past from a cost-benefit standpoint. And let's take a fresher look at that. And now, assuming, again, additional upside and assuming a more streamlined way to go about it, like do some of those at least to start making more sense. Once you have that and you really understand that there is value, right, and be certain about that there is also value on the business side, not just on the technology side, because this will ultimately be a change management challenge, right? Once you validate that, then the next step is to create a POC, or even better, an MVP. So pick one of those or a subset of them and test it. And test it not just to test the tools or to validate that it can work from your source code to a more modern source code, but test it so that you can actually develop your own methodology, your own approach on how you're going to do that within the enterprise, and ultimately test and learn and stand up the factory that's going to go through this process going forward, right? That's really what that POC or the MVP step should achieve. And then from there, it's about scaling, right? Scaling into other domains, scaling into other technologies that you have, and then just sort of accelerating adoption. We've seen this model where, the initial team that works through it can then be split and helping in other areas, and all of a sudden, as you improve your own efficiency on doing this, and obviously as the technology continues to mature, as we've been seeing, right, so rapidly, more and more of those business cases that didn't make sense before will start making sense now, right? So if you get into this journey, it becomes a bit of a snowball effect, right? And as you get better, as the technology gets better, more and more can be done with it. So again, I think the time to start is now.